Welcome to the deep dive. Today we're jumping into something really fascinating. It's from a document you actually shared with us.
That's right. And it sets up a pretty unique challenge, doesn't it?
It really does.
Asking us to explore this potential link between pure mathematical concepts.
Yeah, differentiation, derivatives,
Yeah,
stuff I remember dimly from school.
exactly. And connecting that to something very practical like food security.
And even more specifically, sensory analysis within food security.
Yeah,
It feels like a stretch at first glance.
it does. So the mission, as this document lays it out, seems to be figuring out how these connect, or maybe if they connect in a meaningful way.
Okay, so let's try to unpack that. We've got food security over here that's about, you know, availability, access, how stable that is over time.
Right. Things change, dynamics.
And then sensory analysis, how we perceive food, taste, smell, texture, the experience of eating.
Uh-huh. Which also changes, right, during the process of eating.
Good point. And the document suggests the bridge is derivatives.
Yeah. So let's quickly recap. Differentiation is the process, and the derivative is the result. And fundamentally, a derivative measures the instantaneous rate of change.
Instantaneous.
Yeah,
So, like, how fast something is changing at one specific point in time. Not the total change, but the speed right now.
precisely. Think speed, acceleration. Those are derivatives in physics.
Mm.
How fast is velocity changing?
Okay. So the source is basically asking, can this mathematical idea of measuring the rate of change, can that help us understand what's happening in both food security dynamics and in sensory analysis?
Exactly. Could it be a kind of common analytical tool?
Huh. It's interesting. Let's think about food security first. How might a rate of change apply there?
Well, you could hypothetically use a derivative to measure how fast food access is improving or declining for a specific group, maybe month over month, rather than just the overall trend.
So not just it went down by 10% last year, but in March, the rate of decline suddenly accelerated.
Exactly. Or maybe quantifying the marginal impact of, say, a new irrigation technique.
Mm.
How quickly is the yield increasing at this stage of growth? It gives you that dynamic picture.
Right, the intensity of change. Okay, I can sort of see that. But sensory analysis,
Huh.
that feels much more subjective.
It is subjective, but our perceptions do change over time, even in a short period. Think about eating something crunchy.
Okay, like a crisp.
Yeah, the crunchiness isn't constant, is it? It decreases as you chew.
True.
So a derivative could potentially measure the rate at which that perceived crispness is decreasing, or how quickly the initial burst of sweetness fades on your tongue.
Ah, I see. So you could plot like sweetness level over 15 seconds.
Uh-huh.
And the derivative would tell you how fast that sweetness is dropping off at, say, the 5-second mark versus the 10-second mark.
You got it.
Yeah.
It's about capturing the dynamics of the sensory experience. Not just is it sweet, but how is the sweetness behaving over time?
And the core argument from the source is that this same mathematical tool, the derivative for measuring rate of change, could apply to both these, well, vastly different areas. Socioeconomics on one hand, perception on the other.
That seems to be the proposition. It's suggesting that math provides these sort of universal frameworks. Both fields involve change over time, so maybe the analysis of that change has common ground.
It's less about a specific formula linking, say, poverty rates to flavor intensity,
Definitely not that literal, no.
and more about applying a way of thinking, mathematical thinking about rates to both domains.
I think that's a great way to put it. The source material seems to champion this idea of cross-disciplinary application of fundamental concepts, like
Yeah.
seeing the underlying mathematical structure in the real world.
Taking tools like derivatives out of the textbook and seeing where else they fit.
Exactly. How can understanding rates of change help us analyze, well, anything that changes? From global food systems right down to how we experience a single bite of food.
So wrapping this up, we've explored this document's really thought-provoking idea, connecting differentiation and derivatives to food security and sensory analysis via this concept of rate of change.
Yeah, it's a fascinating reminder that mathematical tools can offer powerful ways to, view and quantify the world, even in areas that seem purely qualitative or descriptive at first.
Right. It really pushes you to look for patterns.
It does.
And that leads us to a final thought for you, the listener. If mathematical concepts like derivatives can potentially link something like food access to taste perception, what other totally different fields might be connected by these fundamental ideas of change and rates of change?
What surprising connections might you uncover if you start looking for that shared mathematical language in unexpected places?
Something to think about. Thanks for joining us for this deep dive.